Very good morning and hi to Dr. Kok, Dr. Ng, and all my fellow students. So today I'm going to present my task 3 coursework, which is presentation from the course of Basic Algebra. The course code of Basic Algebra is MTES 1074. So basically this task 3 is going to talk about or related to topic that we have been learned in Form 5 and in IPG, which is the topic 2 linear programming. I'm sure that all of you guys have a clear understanding about this topic. So firstly, I'm going to introduce a little bit about myself. My name is Alexander Kurembo. My index number is 20210623100070. My identity card number is 030313120845. So without further ado, let's jump into the topic. So this is my table of content. There are several things that I'm going to discuss, which is the first one is the introduction. The second one is the identify problem as solvable by linear programming. As we know, there's a lot of problems out there that can be solved by mathematical method, but mathematical method is very general. But if you want to be more specific, there are certain problems that only can be solved by a certain topic. In this case, as our main topic is linear programming, I take out one single problem that only can be solved by linear programming method. Okay, the third one is the diagram. Diagram is the visual way to present the problem so that you can get a clear understanding about the problem. So the fourth one is a formulate a mathematical model of the unstructured problem. So this unstructured problem is actually the second one. Why I called it unstructured problem? Because the problem is not arranged properly, not systematically. We cannot see the mathematical model. So we need to take out all the mathematical model from the unstructured problem. Okay, the mathematical model is divided by three, which is the first one is identify variables. Second one is adjective function, and the third one is constraints. Next, after we got all the mathematical model, we need to solve the unstructured problem. There are two methods that we can use to solve the problem, which is the first one is extreme in the bracket corner point solutions, and lastly is alternative objective function solution lines. We can choose either one to solve the problems, but in this video, I'm going to show to you guys both of them on how to solve the problems by using these two methods. Next, explanation in details. After we got all the solutions, I'm going to explain it more details about the relationship between the solutions and the unstructured problem. After that, lastly, the conclusion. The conclusion I'm going to conclude all these things that we have been learned into one. So, without further ado, let's move on to the first one, introduction. Linear programming is just really neat method of using math to find out how to best do something like how much stuff to buy or make. It involves something called constraint, which are systems of linear inequalities. Basically, when you want to minimize cost or maximize profits, sometimes the only way you to go about doing that accurately is solving it as a linear programming problem. For a great foundation, here's a course called Algebra 1 that introduces basic algebra skills and principles that would really come in handy in solving linear programming problems. If you ever wondered where it all started, as I'm sure you have, this way of finding answer to pertinent issues was actually developed for solving militarily logistic problems in World War II. These days, it is extensively used in business for maximizing profits and minimizing costs. It helps to clearly understand linear programming concepts and apply this correctly. Knowing basic concepts in math doesn't hurt either. By the way, for a great math foundations, here's a course called Beginning Algebra, building a foundation that makes a great refresher course as well. Next. Situations that benefits from linear programming problems include material utilization decisions, quality control decisions, processing decisions, explorations of oil deposits, fluid blending problems, product mix decisions, marketing, physical distribution decisions, warehousing decisions, productions planning, and long-range planning. This attracts the attentions of many practicing executives since many problems that come with managing companies usually have to do with making big decisions under limitation or constraint. Since linear programming deals with optimizing objective desire in circumstances that involve limitations, it does not come as much of a surprise that this particular math equation come in extremely useful, especially in the area where big business is concerned. More specifically, the process of taking various linear programming is unequal amounts that relate to specific circumstances is called linear programming. Finding the best obtainable value with the given condition is what you attempt to solve for. This is the field of math that is concerned with minimizing or maximizing linear functions that have constraints. To solve for problems of linear programming, you need to meet the constraint requirements in a way that minimize or maximize the objective functions. It is important to solve these types of problems, and in many fields like economic, business, and operation research is quite useful. Some of these problems even come out in standardized tests in school. So we are complete for the introduction. Hopefully you guys understand about the linear programming. So let's move on to the second one, which is identify problem as solvable by linear programming. I just take out one single problem that can be solved by linear programming. Okay, let's read out. A factory produces two types of pills, which is the first one is the pill M and the second one is the pills M. From the mixture of vitamin C and vitamin E, each bottle of pills M contains 200 grams of vitamin C and 300 grams of vitamin E, while each bottle of pills N contains 100 grams of vitamin C and 350 grams of vitamin E. On a certain day, the factory is supplied with 18 kilograms of vitamin C and 42 kilograms of vitamin E. Then the number of bottles of the pill N produced can be more than 3 times the number of bottles of the pill M produced. Furthermore, the profit obtained from the sales of the pill M and the bottle of pill M are 10 ringgit and 8 ringgit respectively. They have arranged to maximize the profit that can be obtained by the factory. So basically, there's a lot of mathematical model that consists from this text, but we cannot see here if we just look it like this, but there's a lot of constraint here. So in general, we can see that the factory wants to maximize the profit. So how can the factory maximize the profit? They need to determine how many products that they can produce so that the products can be sold to maximize the profits. So basically, the more the products that been produced, the more the profit that can be obtained by the factory. Okay, so we finished for the second one. Now we're going to the diagram. Okay, this is the diagram. Okay, based on the diagram, we can see the process of making pill M and pill N using two types of vitamins, namely vitamin C and E. In addition, the stock of vitamins is also limited where vitamin C has 18 kilogram while vitamin E has 42 kilogram. Finally, the price of a bottle of pill M and N are 10 ringgit and 8 ringgit respectively. A factory wants to find the maximum profit that can be obtained using the linear programming method, where the factory needs to find a model, which is the identify problems, objective function, and constraints in order to use the graphical solution method to solve this problem. Okay, the first diagram, as we can see, is the table. Okay, the product of pill M. The pill M requires 200 gram per unit for vitamin C and 300 gram per unit for vitamin E. After we produce one bottle of vitamin M, then the factory sell the bottle of vitamin M. They will get a profit of 10 ringgit for each bottle. Then the pill N requires 100 gram per unit for vitamin C and 350 gram per unit for vitamin C. So if the factory sell one bottle of pill N, they will get a profit of 8 ringgit per bottle or per unit. Okay, this is the second diagram. This is actually the similar things for the second and the first one, but this is more clear lah. Okay, for the first bottle here, we can see the labels here is pill M. The price for this bottle, one bottle is 10 ringgit. So the contents for this pill M is 200 gram for vitamin C and 300 gram for vitamin E. For the pill N, the bottle of pill M, the price is 8 ringgit for each bottle, and the contents for this pill N is 100 gram for vitamin C and 350 gram for vitamin E. Okay, the last diagram is talking about the stock of vitamin C. As we know from this text, the vitamin is limited, where the vitamin C only has 18 kilogram and vitamin E only has 42 kilogram. If we convert it into gram, we can get 18,000 gram for vitamin C and 42,000 gram for vitamin E. So we're finished for the diagram. Let's move on to the for the fourth one, which is the formulate a mathematical model of the unstructured program. Mathematical model, they have three things here. As we can see, identify variable, objective function, and constant. Let's move on. The fourth one. Okay, decision variable. The factory needs to determine the unknown for each variable whose value needs to be searched to determine how many products it wants to make in order to maximize profits. The products are pill M and pill N. The purpose of determining this unknown is to ensure that each axis in the graph is represented by the variables that the factory is X and Y as not as unknown. Okay, why we need to find this variable? Okay, the first purpose is determine how many products it wants to make in order to maximize profits. So this mean is the factory want to find the product all of M, pill M, and the product of pill M that can be produced, so that the factory can maximize their profits. Okay, not only we can maximize the profit, we also can minimize the profit, but this not make sense for one factory to minimize their profits. Yeah, all factory or all company want to maximize their profits. So in this case, they want to find out how many products that they want to produce so that they can maximize the profits. So this is the purpose to find the variables. The second one is determining this unknown is to ensure that its exists in a graph is represented by the variables. As we know, if we want to solve any problems related to linear programming, we need to solve it in graphical solution. So talking about the graph we have horizontal line and vertical lines. So which mean we need to find the unknown for horizontal axis and unknown for vertical axis. So we need to find two unknown here. So the factory I need to find two unknown. So the factory use X and Y. For your information, any unknown also can be used like MN, KL, AB, and other more. Many more. Okay, so how can we present this X and Y? So X is the number of bottles of pill M to be produced, and Y is the number of bottles of pill N to be produced. Okay, this is the decision of variables. Next, the next mathematical model is objective function. Okay, let's take a look. The factory also needs to set the objective function z in order to ensure how much profits can be obtained when each pill M and N is sold. In this case, the factory needs to find what is the highest value of pill M and pill N can sell to maximize profits, since pill M and pill N cost at 10 ringgit and 8 ringgit respectively. Then the equation for Z can be determined as below. Okay, from this deck, we can see that uh, the purpose to find this objective function is obviously to ensure how much profits can be obtained when each pill M and N is sold. This I already mentioned previously. Okay, the second one is needs to find what the highest value of pill M and pill N can sell to maximize profits. So obviously, if one factory want to sell the products, the highest product can be sold, the highest profit that they will get. So in this case, the factory wants to find the highest value of the product of pill M and pill N that can be sold, so that the factory can maximize the profits. Okay, since the pill M and pill N cost 10 ringgit and 8 ringgit respectively, actually the price, this is a typo. Okay, 10 ringgit and 8 ringgit respectively, then the equation for Z can be determined as below. So since the factory wants to maximize the profit, so I put here as a maximize of Z equal to 10. What is the 10? 10 is represented by the 10 ringgit. Okay, what is X? X, as we can see here, X is the number of bottles of pill M to be produced. Okay, so if we 10 ringgit times X, we will get the profit for the pill M that been sold only, the pill M only. So for this is the pill N. Why? At this at is presented by the at ringgit, the price of the pill N. So what is the Y? Y is the number of bottles of pill N to be produced. So at times Y is equal to the profit of the pill N that been sold. Okay, so that's specific, but if we add it, adding all it up, we can get the total of the profit that can be obtained by the factory, where Z is the profit that been obtained by the factory. Next model is constraints. Based on the problem situation in 2.0, which is the second one in the table of content, there are sections that can be quoted as constraints. In addition, there are two types of constraints, which are resource and non-negativity. The constraints that can be taken are as follows. Okay, basically, constraints have two types, which is the resource and non-negativity. What does it mean of these two types? Okay, resource is the constant that we can get from the problem text itself. So the text itself, we can get the constant, but the non-negativity is a fixed rule that we need to use in any linear programming problem. Okay, for the resource constant, the first constant that we can get from the text is, for making a bottle of pill M requires 200 gram of vitamin C, while pill N requires 100 gram of vitamin C. The available vitamin C stock is 18 kilogram, equivalent to 18,000 gram. Therefore, the factory can only use vitamin C less or equal to 18,000 gram. So 200 and 100 is the gram for the vitamin C. Okay, X and Y. X is the bottle of pill M, and Y is the bottle of pill M. So if we add it all up, they will get the total amount of vitamin C that been used. Okay, why less than or equal to 18,000? It is because the vitamin C stock is limited, where the vitamin C only have 18 kilogram or equivalent to 18,000 gram. So the factory only have to use the vitamin C less or equal to 18,000 gram. They cannot more, because the vitamin C doesn't enough. Okay, for the second one, it is actually similar to the first one, but the difference is the vitamins, which is the first one is vitamin C and the second one is vitamin E. For making a bottle of pill M requires 300 gram of vitamin E, while pill N requires 350 gram of vitamin E. The available vitamin E stock is 42 kilogram, equivalent to 42,000 gram. Therefore, the factory can only use vitamin E less or equal to 42,000 gram. So here we can see is 300 and 350 is actually the gram for vitamin E. Y is the bottle of M, and X is the bottle of M, and Y is the bottle of M. So if we add this all up, they will get the total amount of vitamin E that been used. So with Y less than or equal to 42,000, it is because the vitamin E is very limited, where the stock is only have 42 kilogram or equivalent to 42,000 gram. So the factory only have to use less than this amount. Okay, if we make it smaller, we can get 2x plus y, less than or equal to 180, and the second one is 6x plus 7y, less than or equal to 840. The third constraint here is the number of bottles of pill N produced cannot be more than 3 times the number of bottles of pill M produced. Okay, this is basically the conditions to produce the pill N and pill M. So pill M is the Y, and the pill M is the X. So the cannot be more than 3 times the number of bottles of pills M. So 3x and Y, the condition to produce pill M and pill N. Okay, next. This is a non-negative constraint that I told that is a fixed rule. Okay, the first one is X is more than or equal to 0, and Y is more than or equal to 0. Okay, this is the complete linear programming. Maximize uh, Z is equal to 10x plus 8y, subject to 2x plus y is less than 180, 6x plus 7y is less than or equal to 840, y is less than or equal to 3x, x and y is more than or equal to 0. So we are finished for the mathematical model. Then we need to solve the unstructured problem by using these two methods. Okay. The first method is extreme, in the bracket point solution. Okay, the first step is plot the constraint as equation. Okay, we need to use the three constraint that we have, the resource constraints, to make it as a equation and to plot the uh, to plot the graph, to plot the line in the graph. Okay, why I do this table? We do these tables is in order to find the 2 points so that we can connect the 2 points to make a single straight line. Okay, okay, for the first constraint is 2x plus y is more than or equal to 180. We can change the symbol into equal to, because we want to make a graph. We need to make a straight line. So if we substitute 0 to x, the y will get 180. If we substitute 90 to x, the y will get 0. So this is the two coordinates here, two coordinates. So if we plot it, two coordinates here, one here, and the two here, then we connect it. So this is the first straight line that we can get from the first constraints. Okay, I already label it. Okay, the second one is 6x plus 7y is less than or equal to 840. If we substitute 0 to x, the y will get 120. And we substitute 140 to x, the y will get 0. The same thing as the first one, then plot it and connect it. So we can get the second straight line, the blue line. Okay, the lastly is y less than or equal to 3x. If we substitute 0 to x, then y is also will get 0. And if we substitute 60 to x, the y will get 180. Okay, this is the coordinate first, and the second coordinate is here. So 0, 0, 0, 0 is the origin. Okay, and the 60 and 60 for x, y is 180 is here. So we connect it, then we got the third straight line. Okay, this is talking about the step one. Then the step two is shade a constructed according to the inequality symbol of its constraints. So if we want to shade the, if we want to set the constructed, we need to take a look of the symbol. Okay, if the symbol is less than or equal to or less than only, we need to shade the straight line under the straight line. Okay, so the first one is less than or equal to, so we need to shade under the line. Second one is less than or equal to, also shade under the line. And lastly is less than or equal to, also shade the line. Okay, this is the step 2. Let's move on to the step 3. Determine the feasible solution space. Okay, what is the feasible solution space? As we can see here, the feasible solution space is the intersection between all the shaded region for the first, second, and third shaded region. But we need to determine the feasible solution by look at the intersection between all the shaded region. So this is shaded region. Okay, so this is the shaded region, and we call it as a feasible solution space. Okay, then don't forget to plot the vertex, all the vertex for this feasible solution space. Okay, we can see here this is triangle form. Okay, we finished for the step 3. And determine the solution points and optimum points, which mean we're going to determine two things here, which is the solution points and optimum points. Okay, what is solution points? Solution point is simply set the all coordinate for this all vertex a, b, c, and d. So we need to determine it first. So as we can see, a is obviously 0, 0. Why? Because it is origin, right? 0, 0. So the most difficult things, a little difficult, is the B, C, the B and C. Why? Because the B and C, we cannot simply just predict the the coordinate, because we cannot see here, right? This is not the exact value. So how we can get the exact value. Okay, as we can see, the straight line here, the red and the blue line is the intersection, right? The intersection point is the point B, right? So how can we get the point B? Yeah, we need to make simultaneous equations for these two equation, the blue line and the red line. Okay. As you can see here, for the first equation is y is equal to 3x for the first equation. The second equation is 6x plus 7y equal to 840. So we substitute the first equation to the second one, this one, and we got 6x plus 7 times 3x is equal to 840. Then if we multiple this, we can get 21. Then 21 plus 6 is 27. X equal to 840. So if we uh, divide both sides with 27, the left side will get x only, and the right side is 280 per 9. So if we want to find the y, we can simply just substitute the x into the first equation back. So here the answer 200 per 3. So the point B value, the exact value is here 280, 280 per 9 for the x, 280 per 3 for the y. So the third one is the point C. Okay, the point C is here, the intersection between the blue line and the green line. So we can use also simultaneous equation. Okay, the first equation here says 2x plus y equal to 180. The first equation. The second equation is 6x plus 7y is equal to 840. 840. So there are the third equation. Why? Because we need to find the equation that is the unknown is 1 for the left side or the right side. So we just take the equation and just make it as one single unknown for the left side. So this is the third one. So the third equation need to substitute to the second equation. So we can get this equation. 6x plus 7 times 180 minus 2x in bracket is equal to 840. Then if we calculate expand plus and minus 8, we can get negative 8x is equal to negative 420. So if we divide by both sides negative 8, we can get x is equal to 105 is per 2. Okay, if we want to find the y, we can simply just substitute to the third equation. Then we'll get 74. So the point C is 105 per 2 for the x and 75 for the y. Okay, the point D is obviously 90 0, because as we can see here, this one, this exact value. So can no need to find it by using simultaneous equation again. So we are finished for the solution points. Okay, this are also important parts. Since the numbers of pills numbers cannot be in decimal point form, the coordinates for each corner of the visible space must be rounded to nearest digits, which mean just imagine the a bottle of pill, any pill cannot be in decimal point, because we cannot say that the bottle of pill m is 1 per 5. We cannot make it off, or we cannot make it 1 over 4 and any decimal point. So we need to round that it to the nearest digits. So point A, no need already because 0, 0. Point B. Okay, the point B, the x-axis actually 3.1.1. So we just simply put here as a 31. This is 280 per 3 is 93 per 2. So we just put it as a 93. Okay, so the point C here is 105 over 2 is actually 22.5. So we rounded it as a 53. So why 72? because if we substitute this 73 uh, into the third equation, we will get the 74. So the point D, no need already, 90 and 6. Okay, this is the most important part, the optimal solution points, which the purpose that we can, which is the solution that we need to find to solve the problem. So the point A, if we use the point A, 0, 0. What the meaning of 0, 0? What the meaning of the point here? This is the X, right? Which means the battle of Bill M. And this is the Y, which is the battles of pills N. So if you substitute, they won't get anything. They get a zero profit because there's no productions of the products. Okay, so next the point B. Point B, the bottles of pills M is 31 and the bottles of pills N produced is 93. So the profit that they will get from selling all the products is 1054 ringgit. And point C, X is 53 and Y is 74, then the profit that they will get is 1122. And lastly, the point D is 90 and 0, then they will get 900 ringgit. Therefore, the optimal solution is point C as it is the highest value among other points. Okay, so point C is the optimal point, or in the other words, is the maximum profit that they will get for the point C. Okay, this is the first method. Now let's take a look for the second method, which is the alternative objective function. Okay, the step one actually is the same thing, so I'm not going to discuss about it. Step two also the same, and the third one also the same, and this is the different. Okay, step four, plot a objective function line. Okay, uh, this is the same as the constraint. We need to use the equation to make a one straight line. Okay, this is the objective function z. Now we need to find a right value to substitute to the z so that we can get a one equation so that we can plot the equation as a straight line. So I put here as a 800. So similar to the constraint, we need to use a table so that we can determine the two coordinates so that we can connect the both coordinates, the points. So if we substitute 0 to x, the y will get 100. If substitute 80 in x, it will get 0 for the y. So we plot 2 and connect it, then we will get the objective function line. Okay, this is step 4. And next, identify optimal solution point by dragging the objective function line to upward as the factory wants to maximize the profits. Okay, if you want to maximize something, you need to make it upward. You need to drag it upward. Or if then uh, if you want to minimize something, you need to dragging it downward. So since the factory wants to maximize the profits, we need to dragging it upwards until the last corner of vertex. Okay, we drag all of them, then after the last vertex here, we got 4, right? So the last vertex here is represented as a optimal point. Okay, the optimal point is the point where the maximum profit that we will get. Okay. Based on the observation of the graph, when the objective function line touches the last vertex in the visible space when dragged upward, so the coordinate of the vertex is marked as the maximum point. Therefore, the optimal point in the graph is point C, 52.75. This is the exact one, but since the number of pairs cannot be in the form of decimal point, then the point C is 53.7 and 74 approximately. Therefore, the maximum profit earned by the factory is Z is equal to 10 times 53 plus 8 times 74 is equal to 1,122 ringgit Malaysia. Okay, the last step, checking the constant to make sure it makes sense. Okay, this step is continuous of the method 1 and method 2. Okay, Okay, so from the method one and method two, we got the same optimal point, which is the 53 and 74. So the first constraint is we need to substitute x and y. So x 53, 74, and we just adding it up, and 100 is less than or equal to 180. 180 is less than or equal to 180. It makes sense. Why? Because the symbol is tell us that, I'm sorry. Okay, so 100, so the symbol tell us that uh, less than or equal to, so even the value, the right side and the left side and the right side is equal, so it makes sense because the symbol is told us or equal to, so it makes sense. For the constraint 2, is we substitute, we also substitute it, then we calculate, we can get 860, 836 is less than or equal to 840. So obviously it makes sense because this is less than or equal to 840. For the constant 3, y is less than or equal to 3x, we substitute, then we will get 74 less than or equal to 159. So this is very obvious. So it makes sense. So we just complete the solve the insertion problem. Now we're going to explanation in details. Based on the problem solving through the graph in two methods, namely alternative objective function solution lines and extreme in the bracket corner point solutions, we find that the optimal point is used as an indicator for the factory determine the numbers of M and N pills bottles that need to be produced to get maximum profit. Therefore, the optimal point obtained is 5374 roughly. Then the factory needs to produce 53 bottles of pill M and 74 bottles of pill N in order to get a profit of Z is equal to 10 times 53 plus 8 times 74 is equal to 1122 ringgit Malaysia. In addition, the optimal point obtained certifies the constant weight. It shows that the optimal point is the solution to the problem in station 2.0. Okay. Now, the last part is the conclusion. In conclusion, linear programming has proven to be an extremely powerful tool, both in modeling real-world problems and as a widely applicable mathematical theory. Linear programming theory falls within convex optimization theory and is also considered to be an important part of business and economics, but may also be used to solve certain engineering problems. The topic of linear programming should be retained in the student's mathematics subject because the method of the topic can be used to solve many problems that arise in the future that we might think it is thought cannot be solved. After performing this task, I realized that linear programming is a very interesting topic. It is not only to be learned, but it can be used method to solve various problems that arise. I am also aware that linear programming needs to be learned by everyone, especially individuals who are in business, so that they are able to maximize and minimize something that is desired. That's all from me. Thank you.